Hi, I'm about to do a Zoom report for Module 1, my course overview for quantitative literacy, and I'm Amy Benzi. In my Zoom report for Module 1 for our course overview, I'm about to share my screen, and I am going to show you my Excel spreadsheet. I share my screen, double-click on desktop, and now you are seeing in Zoom what I see on my computer screen. And I'm going to look at my Zoom report here. Oh, cool. So I can make this full screen. I know I'm talking a little bit extra. I can make it full screen and still have my video up here. And when you guys are working in groups, all of your little videos would be right here on the side while you take turns showing your presentation. Super easy, you'll see. All right, my Zoom report here. For number 1, we looked at a sneaker company. We saw that the initial investment of the sneaker company was about $240, which is shown on the graph right here with the yellow dot. The bottom dollar that the company did was about $304. And right now I'm looking at a table and a graph that go along with the function that defines the profit of the company depending on the number of sneakers that are sold. I can see that on my graph right here at about 13 pair of shoes highlighted in blue on my table, the company broke even. And then at the red dot and the red highlight on my table, the company reached about a $500 profit. And it looks like if this company continues selling shoes at the same rate, they will be very prosperous. For part 2, we were looking for probability of dice rolling. If I rolled 2 die, what's the probability of rolling a sum of 5? These little charts give me a sum of rolling a 1 and 1, a 1 and 2, a 1 and 3, and then if you look all the way over at the bottom right-hand corner, I had a sum of 12, 6 plus 6. The probability of rolling a sum of 5 is 1, 2, 3, 4 out of 36, which came out to be about 11%. Here, the sum of rolling a 4 or a 9 came out to be 7 out of 36, which was about 19.5%. The probability of rolling doubles was 6 out of 36. Six different ways to roll doubles out of 36 possible ways things can happen. Came out to be about a little over 16.5% chance of rolling doubles. And then the probability of rolling just a sum of 12 was 1 out of 36, which was only about a 2.8% chance. Rolling a 12 was the least probable outcome of all of the outcomes in this problem, and then the most likely outcome would be rolling either a 4 or a 9 had the highest probability for this problem. Number 3, we're looking at building some different histograms. I had some ways that I could make my histograms move around and change shape depending on which random numbers were used to create my histograms. And I show all different kinds of shapes. I also calculated the mean, the median, and the standard deviation for each set. And then I Googled and looked up some information to find out about measure of center, which I found out measure of center is the mean or the median. The spread of the data, how spread apart the data is, was my standard deviation. A large standard deviation means my data is really spread apart, and a small standard deviation means that all my data is really squished together. And I could have outliers. If I have an outlier on the far left side, I would have a skewed left. If I have an outlier on the far right side, I would have a skewed right. Different distributions that I can have, and data can be normally distributed, which means that my histogram looks like a bell-shaped curve, which you can actually see in my next problem down here, or my data could be skewed left or right. Also, when I'm looking at a bell-shaped curve like I am in this problem where I'm looking at SAT scores for the early thousands, I can see that the average score was 1,068. There was a standard deviation, which means the data was spread apart by 230 on each side. The first standard deviation is the mean, the average minus 230, and then on the right is the average plus 230. And then I had to calculate the percentage of the people who scored between 838. I'm sorry, first I have to find the probability that a person scored over 608. Well, 608 was right here on the first standard deviation, and I can see on my little chart right here that the first standard deviation, these are my percentages. I added them up and I found the percent of the population turned out to be about 97.7% scored more than 608. The amount of the population that scored between 838 and 1200, well, if you look here, 838 to 1200 is within the first standard deviation, which is these two parts. And guys, I'm just showing you how to make a Zoom video. We're actually going to learn how to do this in the modules. So, you know, you will actually get your lessons and your homework will help you learn all this stuff. But anyway, within the first standard deviation from 838 to 1298, I can see that 34.1 plus 34.1, it looks like about 68.2% of the population scored in that range. And then I took 68.2 and I multiplied it by 460 because it says I had 460 students. And I'll just show you guys real quick. If I want to show formulas, I go up here to formulas, click show formulas, and here I am showing you all the formulas that I used. So you can see that right here I did 68.2% times 460. That's 68% of 460. Anyway, I'm not teaching this lesson, I'm just showing a Zoom report, sorry. And so it looked like we expected about 314 students to score between 838 and 1298. And then lastly, we combined the last two problems, number 5 and 6, into one, and we created a chart to show Edwin's fixed expenses. We created another chart to show the percentage of each of his incomes, as well as what percent that was of an entire circle. And we did that in order to create this pie chart. And we created this pie chart to show how much, give a nice visual of how much Edwin spends for each of his fixed incomes. That's my Zoom report for Module 1 exam. Don't forget, always show your formulas within your Zoom report. Very important to show those formulas. All right, I am now going to stop my screen share. Stop screen share. Then, in order to upload this video, I have to end my meeting. So I'm going to now end this meeting.